Okay.
Some of the concepts behind this work. Hi, I'm Rob Atkinson, a Senior Research Engineer at the Open Geospatial Consortium. I'm going to give you an overview of some of the concepts behind this workshop using RDF and SPARQL for data integrity checking. So this project is part of one of two projects looking at the automation of compliance checks for digital building permits. The check project is very much focused on the mechanics of getting data and executing rules, and the Accord project is about the semantics and defining those rules in a reusable way, and obviously the two dovetail together. So the question here is, first of all, why is this problem hard? Why hasn't it been done before? Why are we doing it now? So let's have a look at some of the realities of the situation. There's obviously lots of data about our built environment. This data, there's lots of different standards for what this data may look like. There's lots of flexibility in how those standards are used, and there's lots of variation in the subtle details about what data is put inside those standards, what terminology means. So types of data, obviously there's things like building design models, there's cityscape models, there's land use planning models, and there's potentially other types of environmental data which may be relevant. Many sources of information, they're not terribly harmonized. So the question really is, well, where do standards fit? If we start looking at some of the standards, one of the things which is common is this concept of levels of detail. But of course, there's many different variations of that. And as you get into more detail, these are increasingly hard to standardize and to choose the exact same set of choices. So we have many different people delivering data with different flavors of standards depending on what level of details they choose. Even within a particular standard, there are often multiple ways of doing something. So a quick example here is from the industry foundation classes, showing that there's actually multiple ways of describing a wall, for example. There's also quite a lot of variability in how expressive the various standards are for things, for example, the relationship between geometry and topology, and how much detail can they come through. There are simple, relatively easy to use standards for geometry which ignore topology, and obviously if you need to explore some elements, then you need to have more complicated data models. So we've obviously got a situation where we've got multiple organizations generating standards addressing different aspects of this data. And within this, we also have complexity because there is subtle difference in the semantics. Things like distance is something surveyors have to pay a lot of attention to, depending on how you presume the Earth's surface is calculated, and what elevation you assume, and the shape of the Earth, and lots of different flavors. Things like building heights and number of floors and those sort of things. There's a lot of variability in the subtle semantics. And then, of course, in the technologies themselves, we have a lot of different variations, right down from the language to character encodings, the different syntaxes in use, different ways geometry may be described, and then the application schemas or the data models that describe all the objects, many different flavors of those out there. So with all that variability out there, which people naturally have done things in many different ways, the question is, what aspects can we reuse to achieve the goals of being able to define rules that we can do compliance checking on? Well, so to define the rules we need to be absolutely clear about the semantics and what these rules apply to. And that means being able to link the semantics to the way the data is structured. And what we're going to do in this workshop is demonstrate how a small number of standard approaches can be combined to achieve this for a wide variety of different input sources. So the sort of pipelines that Alejandro will demonstrate basically will take data through from the sort of source data into typically a thing called JSON, JavaScript object notation. And then from there, we can transform this to a common semantic model and then start running rules. And we'll go into more detail as the workshop progresses. So a quick summary of what you're going to learn in this workshop and which components are doing what. So one of the first things is we need a way of expressing things in general. And this concept of RDF, the Resource Descriptor Framework, allows us to have explicit semantics about what things are and allows us to have data structures with arbitrary nesting. But it's built on this concept of universal identifiers for each concept and each object. And that allows us to have rules which reference these things. Then we need the ability to execute the rules, and this is where the couple of standards that can then exploit this RDF expression are available. So we have SHACL, the shapes constraint language, which is quite powerful, and it wraps an even more powerful general purpose language, SPARQL, which is like SQL if you're familiar with that, except that it easily handles recursive nested structures, and it also easily allows extensions to data models without having to manually join tables. But it's a steep learning curve. We don't expect everybody to be able to handle that, and it's not easy. So what we can do is we can define a rules definition language which is easier to use, powerful enough for the job. And for this, we are going to demonstrate the use of JSON templates, which is a very common technology and has a standardized mapping to RDF. We don't have to invent anything new. And we can simplify these further into parameterized templates once we understand the rule patterns. And these simplified parameter sets can be turned into spreadsheets. But we're going to focus in this workshop on what these JSON patterns might look like for some of the rules and how those can be executed. So on with the show. I'll leave it to Alejandro to walk through the mechanics of this. Thank you very much.
Going to start with my actual presentation. As you already know from the agenda for the workshop, we have we're going to have two parts, one more theoretical and one more geared towards practice, towards the actual rule implementation and profile implementation, which is basically making what Rob has been talking about for the past few minutes into something concrete, right? So let's start with the general workflow of our validator or our methodology, better yet. So basically what we're going to be doing today is we're going to use a set of tools that we have developed for the Check project, in which the central part is a validator that can transform input CityJSON files. It can also deal with CityGML, but we're doing that through the use of another tool called the CityGML tools to convert CityGML into CityJSON. For those that are more familiar with CityGML than with CityJSON, basically CityJSON is a simplified implementation of the CityGML model, obviously based on JSON instead of XML, given the name. And it's not a full implementation of the CityGML model. Its creators claim that it covers around 97%, something like that, of the actual use cases out there. But for our purposes, for the purposes of this workshop, this is more than enough. So basically, we can take CityJSON files. We have a process called the semantic uplift, through which we convert those CityJSON files into semantic format, into RDF specifically. And from a set of input CityJSON documents, we create an RDF dataset. And then on the other side of the equation, we have a set of, just the pointer in here. So we have a set of rules, well, this would be more appropriate, right? We have a set of data requirements, which is what our application currently deals with, right? Data requirements, the fact that we have all the necessary inputs and potentially in the required format available for us. Those data requirements are translated into what are called SPARQL shapes. Rob has talked about SPARQL very briefly. I'll introduce it with a little more detail later on. From that, we can group several SPARQL shapes, several validation rules. We can group them into what we call a profile, right? A profile is a specification that can group several, for our purposes, several validation rules, right? Another characteristic of profiles is that they can reuse other profiles, right? We can inherit rules from other profiles, so we can compose, right? Through composition, we can create new profiles that reuse what already exists in other profiles, and we can further constrain it, right? We can do specializations. We may have a profile for the sake of an example, we can have a profile that requires that roads are present in the data set, but then we can have another profile that constrains that not only checks for the existence of roads, but also it requires that the roads have a specific level of detail, right? So we can store those profiles either on platforms such as the OGC Rainbow, or like we're going to be doing today, OGC building blocks. Again, I'll talk about this in a minute. So once we have our inputs transformed into semantic format, and we can select, I don't know why it's doing that, but we can select a set of profiles to validate our data against. And from that, we'll get a validation report. So basically, what we're going to be checking is whether our inputs conform to a profile or set of profiles. That's what our validator does. Right? Apart from that, we have this box in here, which is about 3DT, which is a tool developed by TU Delft. And what this library does is it validates certain aspects, not everything, but it validates most of the geometries, right? So that we can also check that the geometry definitions that we have in our input data sets are correct. I would also like to mention that we're doing this way because initially we based our tool on CityJSON. So we do first a conversion when we're working with CityGML. We first convert it into CityJSON, but that doesn't have to necessarily be the case, right? We could, although we haven't done so, we could definitely create another semantic uplift process to convert CityGML directly into our RDF semantic model. Please, if you have any questions, you can put it in the chat. You can raise your hand. You can interrupt me as much as you want, and please do so, because I would like to keep this as interactive as possible, not just me talking into the void. So any feedback is appreciated. So for the semantic part, what we're converting the input CityJSON or CityGML datasets into is RDF. RDF, which stands for Resource Description Framework, is a worldwide consortium standard to describe stuff, right? To describe resources, and resources can be almost everything or everything potentially. We can describe real world things. We can describe abstract concepts, documents, properties, people, animals. Basically, the basic tenets of RDF are that we assign identifiers to whatever we want to describe, right? We represent these descriptions as subject, predicate, object triples, right? For everything we have a subject, a predicate, an object. And then we link resources by using this subject, predicate, object scheme. Right? So, for example, we can take data. This is a JSON object that some of you or many of you are familiar with. And we, in this case, for example, if we wanted to describe this according to RDF, we would use the ID to generate a URI, right? And we would have a triple, a subject, predicate, object triple for the age, right? We would assign also another URI to define the age with a value of 38. We would the same thing with the name with a value of 1, and then we'd have a children property with a URI as well, and this would point to these other resources that would also be URIs, right? So in the end, what we end up building is something like what you can see on the right-hand side here, which is basically we build a graph, right? We build a graph through the use of subject, predicate, object, subject, predicate, object, right? And we can build a graph that spans different databases or data sets, and that is what we're doing actually with the data that we consume in our validator. We take the input data sets and we convert them into RDF form and effectively create a graph with the whole thing, right? With if there's only one data set, then it's a graph for that data set. But if we provide 3, 4, 5, however many, we build a large graph, and that allows us to check the graph as a whole, and that allows us to do, for example, we could write rules to do cross checks between the data sets, right? Even if they're not, in our case, we're only going to be working with CityJSON files or CityGML files, but we could potentially have other types of files in the input here, right? We could have other types of inputs, as long as we have a proper model for the semantic format, and as long as the validation rules are aware of the details of those models, we could build a validator that not only checks CityJSON files, but other types of data as well. So I mentioned 5 seconds ago, right? As long as we have a proper target model for our input data. So issue number one is that we don't have a CityJSON or CityGML RDF, what's called ontology, right? An ontology is basically a we could summarize it as a data model in the semantic world, in the RDF world, right? So we don't have a CityJSON or CityGML RDF ontology, not a normative one. There are some examples, there are some exercises. We are actually working with some partners in the core project to build a CRDF ontology, although that's not, again, that's not normative. It's going to be presented as a proposal to the CityGML working group, but still it's not official. So since we don't have anything official, we use our own target model for now, at least. How do we create that target model? Well, we start with we use CityJSON as the base, because CityJSON offers certain advantages over CityGML. The main one is that it's much easier to work with. CityJSON has a very simple structure. It simplifies the object class hierarchy. So and the relationships are also very, very simple and very easy to work with. But also CityJSON can be, as Rob mentioned in one of his slides, CityJSON, JSON is very easily transformed into semantic data. Most of the time, we can just add what it's called a JSON LD context. So a JSON LD context is a mapping from the JSON world into the semantic world. But in our case, we do some additional transformations that I'm just going to describe for future reference, because we intend to, my intention is that you walk out of this workshop with one of or two main takeaways. One is if you have some experience with RDF and with semantics and with SPARQL, you will be able to write profiles with rules of varying complexity, right? So you will be able to do very advanced checks. But if you don't, okay, I'll address that question in a sec. So if you don't have very advanced knowledge about RDF, SPARQL, and other topics, at least you'll be able to create. Because I think Rob mentioned this as well. We're preparing a set of templates with common use cases for rules that are present, for example, in several of the check profiles, right? So we're preparing a set of templates. We already have 3 that we'll be using in this workshop. And you'll be able to at least work with those templates to create profiles, right? So if you can, and if you want to, you'll be able to write very complex rules. I'll show you a couple of examples, but otherwise, at least you'll know that you have the tools to create these profiles, and other additional templates can also be created. So we have a question in the chat. How can you tell if your RDF contains rules or contains model information? Can you provide some more context to your question? So basically, is the question, how do you tell these profile definitions apart from these semantically or these RDF datasets? Is that the question? This one in here, right? Yeah. So basically, because I mean, the properties that we're going to be, apart from, okay, when we do validation through SPARQL, we have to provide 2 different graphs, right? I talked about graphs earlier, basically different data sets, right? So you have to provide 2 data sets, your data graph, right? Your data set, and that's what you're going to be validating, and your shape or rule data set, right? And that's what you're going to use to check, right? To apply. Those are the rules that you're going to apply to your data. How can you tell if your RDF? I mean, you can tell by looking at it, because the definitions, the properties that are used, the classes that are used in one are going to be different than in the other, right? Potentially, you could have it all in the same. There's nothing preventing you from having a huge data set that contains both rules and model information, right? You can mix and match, and you can keep it separate. But it's basically because one, as I'll show you in a couple of minutes, one has, for example, in the case of our city data, it's going to have instances of city buildings, city road, city data, right? And the other is going to have instances of what are called SPARQL shapes, right? SPARQL node shape that applies certain rules to that. But that's as far as I can tell, that's how you can tell. From a user perspective, this one is hidden, right? Unless you want to, you're not going to see what your city data set looks like in RDF. What will be feeding directly into the validator are these shapes in here. Okay. Does that okay? Let's assume that answers your question. So, as I was saying, how do we transform this data? Well, I mentioned earlier that if this is a CityGML document, we first convert it into CityJSON, and that we do with an external tool. But again, we could create a different uplift process for CityGML. We haven't done so, but it's not impossible. And once we have CityJSON only data, we do a couple of transformations. We add RDF IDs. I mentioned earlier how in RDF we assign IDs, URIs, to all resources, or most resources. So that's what we do for city objects, right? A city road, or sorry, a city building, whatever. We assign it an ID. We unroll the geometry semantics. So basically, for those familiar with CityJSON will know what I'm talking about here. But basically, CityJSON compacts the way that it represents the geometry surfaces of a given object, right? So an object can have different geometries with different LODs, and every geometry can have several surfaces, and those surfaces can have semantics. Like, for example, a building can have a geometry with LOD2, and it can have two different surfaces. One is a wall surface, and another one is a roof surface, right? And CityJSON compacts that into an array. So we unroll this to map each semantic surface to its boundaries. We convert the geometries to a topo feature, which the details of this are not really important, but on the next slide, I have some information and links, and I'll share this presentation with you so that you can, if you're interested in it, you can look further into it. We process the vertices. We convert the vertices into a form that we can exploit from a semantic standpoint. Although we're not doing, and I'd like to clarify this. Currently, we're not doing anything with the geometries themselves. We're not doing any geometry calculations. We could, that would be a possibility, but we don't do so right now because, that requires. For that, where am I? Okay. So that requires that this shackle validation box in here, it's basically a shackle capable validation engine, right? So it can read these shackle rules in here, and it can apply those to an RDF dataset. But when we want to do more complex geometry computations, for example, those we need to be able to perform those. The underlying so this shackle validation engine, right? So this is, we have an engine in here. Oh geez, do I have a text? I don't have a text. Okay, so bear with me. We have an engine in here for this, and this relies on a SPARQL query engine, right? So the types of rules, the complexity of the rules that this engine can perform is limited by whatever this SPARQL engine can do. And right now, since, for example, we don't have proper way to work with 3D geometry primitives in semantic space, we cannot do any computations with those. Potentially, if we had a powerful enough SPARQL engine, which is something that it's not it's within the realm of possibility, we could do those computations. But for the purposes of our exercise, we're not going to be doing that. We're mostly or almost completely going to focus on data requirements, right? Data completeness, the fact that we have what we need to have for the rest of the tools down the check pipeline to do their own thing, right? Whatever they need to, conversions, validations, etc. And finally, we add some JSON LD context, which, as I mentioned, is basically adding the mappings from the JSON to the semantic world. I've included in here, again, to serve as a reference, I've included the types of transformations that we do. The geometry prefixes can be edited to add. Yes, they could. I mean, it's possible to have the geometry primitives. That is very much a possibility. We don't do so because we don't have an engine. We don't have a geometry capable SPARQL engine to perform those computations. Potentially, you could definitely do that. And yeah, Peter has a great point that the extra functionality can, I mean, it could become a mess on the one hand, but on the other, thanks if we group, for example, geometric rules or geometry computation rules within their own profiles, we can at least modularize that. But there's not a standard. There's not a set of we have GeoSPARQL to perform certain types of computations and checks and representations of geometries and so on. But for example, the support for 3D in GeoSPARQL is close to non-existent. The upcoming version of GeoSPARQL will potentially deal with this, and it may offer some additional functions, for example, to do computations. And we could potentially, I mean, a plugin, for example, we on our validator, we use RDF which is like the most widely used Python module for working with RDF. So RDF is the SPARQL engine that runs all of these rules. We could potentially create a plugin similar to what PostGIS does for PostgreSQL, right? We could do the same thing. We could have a set of functions that could work with geometry primitives, but that would be a project in and of itself, right? That would be a very, very worthy project, but totally outside of the scope of the ones that we're currently involved in. So, well, just again for there have been conversations about, I've had conversations in the first person about, for example, there could be a case for integrating a PostGIS database into a semantic triple store, for example, right? So that we could have a set of PostGIS functions that are offloaded onto the database. The computations are done, and then the results are returned, or maybe using some kind of microservice that can take care of those computations, and that could be done. But still, it's still all a little too undefined, right? Or yet to be defined. It would be much better if GeoSPARQL supported all these types of 3D functions, so that at least they're standards. Because otherwise, if the names of the functions are not standard, then the problem becomes that the rules that you write for one engine are not compatible with any other engine, and then as the interoperability guys get mad, right? So, but it's definitely an interesting discussion, and I'm very I'd be so happy if we had something for this, but so far we're just focusing on what we can do now. So, couple of things, couple of notes from here. I mean, you can take a look at this at your own pace. But well, basically, we turn all of the city objects and we give them identifiers from their document ID and the object ID. We assign them classes depending on the type of CityJSON object that they are, right? City building, city road, whatever. We preserve the identifiers as DCT identifier. We link them to their specific city. We preserve the parent-child relationships through hasChild and hasParent. We convert function and usage to these two properties in here. We also transform the geometry primitives as topo features, and we offer them as GeoJSON coordinates or as CDY, CDX, CDY, CDZ. We unroll the JSON, the object geometries so that we can have the surfaces have a class of the type of surface if they are semantic or not semantic. The class of the GML type, right? We also preserve that one. We keep the boundaries, although we cannot do a lot with those for all of the reasons that we just went through. And we also keep the LOD, right, as city LOD. Oh, Jesus. So, and finally, we preserved all of the attributes by prepending the utter namespace. The utter namespace, we have the namespaces in here for reference, but basically we convert every attribute into that, right? And the rest of the city JSON elements are just prepended with the city prefix and kept. So this is an example of an RDF, the RDF version of our city, of a city data set. Well, this is not important because these are the prefixes, prefix declarations. But then we have, okay, we have a city in here, right? City. We assign it a URL, URI, sorry, in this case, a URN, city validator, input files. This is to denote that this is the first input file that has been provided. This is the city. It has properties for geographical extent. We can see it here, but it also has transforms. This one didn't have any, but transform and scale. And we declare that it has an object, and this object, this is the definition for an example definition for a road, right? Again, with an identifier. It has just the one geometry, which is this whole object in here, with an LOD of 2, right? That you can see there. The geometry has 3 surfaces, and the 3 of them are surface, traffic area, sorry, and multi-surfaces, right? Multi-surface, 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 and traffic areas. And we have, some attributes in here that came from the original data set. We have boundaries, we have function, usage, and the identifier that the geometry had, the surface had. And we have a relationship to the parent element and the original ID, which is ID 15, that, as you can see, is part of the URI of this object. Right. Any questions so far? Okay, so we can move on, and we're going to start. This is more on hands work. Okay, so now we know what the input data gets transformed into. How do we craft rules? How do we create profiles from those rules, so that we can apply them with a validator. So we have several different ways to do so. We can create the profiles as local files, right? Living in our computers. We can put those into a triple store, but the easiest way to do so is by using OGC building blocks. We could do a whole seminar on OGC building blocks, so I'm just going to give you the cliff notes, and I'll tell you a bit about how to use them effectively just for this use case. But we have lots of resources, documentation, Jupyter notebooks that if Peter, I'll address that in a second, because that is a really good point. So as I was saying, we have lots of resources on how to work with building blocks. We're going to be using building blocks for this, but there are very different. There's a wide array of use cases that can be addressed with the use of building blocks, but you're just going to see a small piece of it. So why function and usage? Why are they transformed like that? So basically, this boils down to them not being standardized, right? We have some code lists that we could implement, and we could, for example, if we were sure that all of the input files are going to be following those code lists, we could definitely use those. We could also have different transform pipelines, right? This processing here, well, or this one, which is the same thing, right? This, especially this part, the JSON and the context, doesn't really have to be unique, right? Doesn't have to be just the one for all of the data sets, but we could have different uplifts, right, or uplift processors to deal with things like exactly that thing that you mentioned, like has function or has usage, right? So that we could map those to their actual values. That's why, it's definitely not semantic. It's definitely ugly. And the workaround is if we need to check for a function or for a given usage, right? We'd have to use the same identifiers, the same numbers as strings, which is even uglier than just the numbers, in our validation rules, right? So the problem here is that potentially one user could be using a given code list for the function property, and another user could be using a different one. And that's definitely an issue. But we can potentially address it in the convalidation time, right? We can say, okay, we're going to validate that the has function has this kind of attribute, this kind of value. So for the check profiles, we have a repository in here, right? Let me, I don't know, I'm not sharing. I can definitely share a copy of the slides. Just give me a second, so that you can all have access to them. Okay. So absolutely, yeah, Alper, and that ties in with very well with Peter's comment, which is if we knew the specific code list that is being used in the input data sets, right? We could definitely map that to as a URI to a given entry in the code list, right? To a given concept, and that is something that again we have just the one uplift process But imagine that, for example, we could create different uplift processes, and you could select when you're feeding data into the validator, you could select and say, okay, no, my CityJSON file conforms to this, which again would be a profile, right? Conforms to this profile that uses this code list for function and usage, right? And that is perfectly, I mean, that is possible, right? That is possible and feasible, and we could definitely do so. Right now, we use the one process, and that comes with these types of limitations. But on the other hand, we don't put the burden on the user, because the idea is that people with extensive knowledge on profiles, on validation, on whatever, are going to be working on this side of things. But we want to simplify it as much as possible for people working on this side, because potentially the people doing the validation of the CityJSON datasets don't know anything or have little knowledge about the specific, code list or uplift process that they're using. Maybe they do, and I'm wrong in my assumption. But that's the way that we've conceived this, and I mean, there's no reason why we cannot do it the other way. But that's the way so far. But yeah, I appreciate the comments, because I mean, I'm really glad that you're seeing the issues, because that means that this at least makes sense, even with limitations. So basically, again, we're gonna be working with this repository. Let me just share this for a second to show you how this looks like. So I'm going to share profiles. Okay, so this is a building blocks register. This building block register has a set of building blocks. In this case, we have two main. We can tag the building block. So we have either check rule template or check validation profile. For example, these are the validation profiles that we have. We have a dummy profile. We have a buildings present profile, roads present, green public spaces, etc. And then we have some. These are all stubs, right? Apart from the roads and buildings, and the Escalpicino one also has some rules in it. But many of these, like the Prague, Villanova de Gaia, Lisbon, those are stubs that are waiting for someone to write the actual rules. So if we take a look at what these building blocks look like, we can see that, for example, in validation, we have, let's see if we can, no, it downloads it for some reason. And we just, can I open it? Well, I can open it, but you're not gonna see a lot. Let me just share my whole screen. Okay, so you can see how this is for those familiar with SPARQL, you can see that this is a SPARQL RDF document. I think it was Nick. Yeah, Nick was asking, how do I tell whether I'm working with, whether I have rules or data in my document? Well, because in this case, this looks like what I have here are SPARQL node shapes, right, which are validation shapes. And in this case, we have a shape that validates that there's at least one road in the data set, right? This is a SPARQL query that returns, a road. If there's a road, it's going to return its identifier, and we're making the rule fail if it doesn't return any value for an object of type road, right? And we have some other more complex checks, like, for example, the Ascoli-Piceno profile, right? In the Ascoli-Piceno profile, to begin with, inherits from, right, buildings present, roads present, and green public spaces present. So the Ascoli-Piceno profile will not only run its own rules, but it will run the rules of these other profiles in here, right? So we don't have to reinvent the wheel every time that we want to create a profile, but we can reuse what's already out there. And if we take a look at the validation rules, you'll see that we have the buildings present rule, the roads present rules, and the green public spaces present rules, right? And what does, for example, the Ascoli-Piceno rule set contain? So we have rules for checking the building of interest. The queries can get as complex as you want, right? So, for example, this is just to do, a bunch of checks. It checks LODs. It checks whether we have a roof surface with an LOD of at least 2. Yes, wall surface inside a building with an LOD of at least 3.1, right? So this performs 7 checks in one, and so this is something like we're going to be, right? This is something that we could create manually, but this is not what we're going to be doing today. Anyone is welcome to create their profiles if they know enough about the structure of the RDF documents and about how to craft SPARQL queries. Then you're more than welcome to create profiles from scratch. But otherwise, what we're going to do is we're going to be using templates, right? So again, to show you a little bit of what this looks like on the, so we can take a look at the, basically, we have a set of profiles in here. We can arrange this into folders any way we want. So for example, for the common one, we can have roads present, and we just need, we don't even need 3 files. We need mostly 2 files. I'll show you in a second. But basically, we need to create a bblock.json file with some basic metadata about the building block. And then we need to create the shackle shapes file, right? But we are going to be doing this again. You're welcome to do this by hand, but we're going to be doing it by using templates. So again, back to the presentation. So how can we create our own building blocks repository? Because the idea in the end is that we create our own a set of building blocks or profiles. In this workshop, we're just going to create one, but we create our own set of profiles, and we point the validator. When we run it, we say, okay, validator, use this building blocks repository as your profile source, right? So we can do so by forking this template in here, right? This template, which is the official OGC building blocks template. It has a couple of examples, but basically we forked this template because it has, the scaffolding for creating building blocks. We create a folder inside sources, like we've seen in the example earlier. We add a building block that we can copy from the check profiles B blocks for one of the already existing ones, for one of the ones in here. We create the shackle shapes. We'll see in a minute how we can do that. And basic definition of this, this is not required for the purposes of this workshop, but since we can add parameters, for example, in the rules, but we're not going to be doing that. And then we push. We push the results and the building blocks get compiled and the application can use those building blocks. One profile can contain, you've seen examples of these, several rules. One single profile can contain several rules. And that's what we're working on. And we can do profile inheritance by using depends on. Right? You also have examples of all of this in this repository in here. I'm just going to paste this is the GitHub repo, and this is the building block list you're seeing in there. Right. So that you have them. Oh, and the template, you have the template in the presentation, but just in case, there you go. Okay. So again, as I've just shown you, we can create rules of varying complexity. I think Rob mentioned this, and I've kind of, I don't know, talked about these concepts, but I haven't really defined them. SPARQL, for those that are not familiar with it, SPARQL is a query language for semantic data, for RDF data, right? It's like the analogy would be SQL language for relational databases, right? With SQL, you can query a relational database. With SPARQL, you can query an RDF graph, which is basically what we do with the validator. And shackle is a specification that doesn't necessarily need to use SPARQL, but for complex rules is definitely useful. Shackle is a specification to define rules, right? To define rules, to define which rules apply to which targets, which types of rules are performed, which types of validations are performed on the target data, etc. Right? So the issue here, again, is that if you want to effectively create a profile like the Ascolificeno example that I've just shown you, you need to know semantic stuff, RDF and SPARQL. You need to know what the RDF data model looks like. I already shown you some, bits and pieces of it, but you need to know it effectively to work with it, including stuff like the function and usage that we already discussed. And then you need to know what your city datasets looks like. For example, if I'm going to check whether my buildings has Windows attribute, I need to know that that is actually a fact, right? That I need my building objects, and the building objects, not the building parts or not the surface, the geometry surfaces, have those attributes. I need to know where those attributes are and how my data set is structured, because my input data set could have buildings and then building parts and then building installations. So the buildings could have installations directly, right? So that requires a little bit of knowledge of what my data is laid out like. So the question then becomes, what if I don't like Shackle and SPARQL, as some of you can see yourselves in this situation? Well, tough luck. Do this works rule? Yeah. We'll see examples of this in the. I'll show you a couple of examples of how these, especially the templates. I mean, if you know how to craft SPARQL queries, you can do almost anything, right? You could write your own query that checks whether the attribute is present. You could check whether, if an attribute is present, I need to have this surface, and the geometry needs to have this LOD. I mean, you can do all sorts of stuff, right? You can say, okay, I want to have something, I don't care what, that has a wall surface, but that something is a descendant CWA. Sorry, what's CWA?
Sorry, the SPARQL is a closed world assumption language, so it falls over if anything is unknown. So I don't see how you can use it for validating real data, where some data may be unnecessary, some data may be missing.
But you can, I mean, you can apply the validations, you can apply those conditionally, depending on whether, for example, you could say, I want to validate that has Windows, the has Windows attribute on a building part, for example, right, has a value of 1 or 0 or whatever I want, but only on those buildings that comply with this set of requirements, right? You can apply the rules selectively, and you can also craft your SPARQL queries to work, to work around those limitations as well.
I'd like to see an example, because
okay,
it's fundamental to, if you're claiming these rules can do compliance checking, then you must show that they can handle less than perfect data.
Okay, yeah, which is basically the point of this, right? Precisely what we want to I guess the number one use case in here would be detecting less than perfect data, right? And calling attention to that, right? But yeah, I'll show a couple of examples. So if you don't like SPARQL or SPARQL, we have 3 already, but we're preparing a set of rule templates, and we can use those rule templates to create rules. So with very limited to no knowledge at all about SPARQL and SPARQL, you can create your own profiles, right? And I'll show how in a minute, and how we can select how we can do conditional selection and all of that. We have the validator published as a Docker. Let me just copy the command because sometimes PowerPoint adds like end of line characters, stuff like that, and that's not always appreciated by command lines. But basically, this is how you can run the validator. Let me just add the command in here. Oh yeah, this is it. So this, for example, will run the validator using our, let's put it in, and use code formatting. No, yes. I don't know why. Code, okay. Damn. I don't know why it's doing this, but this is ugly. No, forget about this. Okay. So that's the command, right? You can, if you have a Docker environment ready on your computer, you can run this the validator locally by running that. And it will be available on port localhost or port 8080. I've the data source in there, the one that I pasted in the chat, pulls the okay, I forgot about adding B blocks from there, but you can use the one that I pasted in the chat, and you can replace the URL to your own building blocks register, to the register.json file that you can find. Just share whole thing in here. So once your register is up and running, right? Once you have created your register, and once you have created your register and you have created the building blocks and pushed them onto the register, a GitHub Pages site will be automatically generated, and it will look like this, right? It will have some. You can actually, if you want to, you can actually clone or fork this repository for yourself, and the website, the GitHub Pages site that will be created, will also include a link to the register.json, which basically will be the URL plus build/register.json, and that's what you can put in the value for the data source, in the URL for the data source that I pasted in the chat. Okay. So again, moving on. So this is what the validator looks like. I think I don't have an instance running, but I can start one. So I'll show you in a sec. But the validator has three tabs, right? It offers three tabs. It has an actual validator tab, an uplift tab, and a rule generator tab. The uplift tab can be used to see the output, the RDF output of from a given CityJSON or CityGML file. So you provide a CityJSON file, and it will show you what it looks like in our version of an RDF version. And the rule generator leverages the templates that I talked about earlier, and it can help you write some rules. And I'm going to show you an example of exactly that. Okay, on screen. So this is the validator running locally on my machine. Well, we can use the uplift. I can take I don't know, roads data set in here. This is a CityJSON roads data set from the city of Ascoli Piceno, and you'll see that it has a lot of output, mostly because the geometries and the coordinates are very verbose, but it also has the objects, the transforms, all of the vertices in the whole city. We could probably omit that, and it has the individual, for example, in this case, the roads, right, with the same limitations about function and usage. But you can see if you're crafting queries by hand, you can see how your data looks like in order to adapt those queries. And then we have the rule generator, and the rule generator, for example, we have three templates: object attribute, object level of detail, and object presence. You can actually see those by going into the our core building blocks repo for check and check rule template. And we have three templates. We have object attribute, object presence, and object level of detail. Object presence, you have examples in here, right? You can copy these examples and paste them in the rule generator, and it will show you the output. But you can see examples in here, and you can see what they look like. For example, in this case, well, let's do the simplest case possible. A rule that checks that at least we have one road, right? That roads exist in a data set. So well, we can give it an ID, we can give it a label to identify the rule itself, a message. This message will appear when the rule fails, right? This is what the validator will return when the rule fails. And then by looking at the JSON schema, we see that we only have Well, we have an object selector, which we can take a look at, and the object selector basically has either a path or a set of ID patterns, right? This is also described in here. Oh no, it's oh yeah, verifies that at least one element follows the parent-child hierarchy defined in object selector path. So in this case, our path just as inside object selector, we have a path and we have road, and this gets translated into this type of rule. And this rule, basically, this is a SPARQL query that fails when we don't have a city road, right? When we don't have a road. We can, and this is where things start to well, this one doesn't really have. The other ones are more interesting in, you know, regarding next question. But again, we can check that there's a list. There's at least one building that has at least one building part as a child, that in turn has at least one building installation as a child. So this is what the automatically generated rule looks like, right? And we could take this directly, this output in here, and feed it into the validator, and the validator will check whether we have that data. For example, we can take this and say object presence, and we can copy the JSON and the rule will get compiled, right? It's basically the same output because it's working with the same constraints, with the same configuration. So we can say, okay, use it in validator, and it will be right. Here for the validation, we can either manually input the data, which is basically what I've done, or you can select a profile, right? You can select a profile in here and say, okay, I want to check this with the green public spaces. But for now, we're going to do one of these checks. And we can, this one requires that a building installation is present. So if we feed it, for example, a roads data set, this should fail. It says validation errors were encountered. Right? And we have two types of validation errors. We have one for Val3D, which is the geometry validator developed by TU Delft, because this is not important for this exercise, but sometimes you're gonna encounter this. 67 features of type road have geometry errors. But then we have another failure of shackle type that says no building installation was found, right? This is the rule that was checked, right? Which is this one in here. My rule roads present, and the value is not important because it's building installation. If we change this to require, for example, like the very same example that we had in here, and we say no, I want to check that at least one road is present. So we generate the rule. We can say use it in validator. And if we feed it the roads data set again, hopefully, if nothing goes wrong, you see the shackle error went away because we have roads now in our data set. So with this, we could write, okay, maybe we require that all roads, I don't know, all buildings have at least a building installation, right? For whatever reason. With this, we can craft these types of rules. Another type of template that we have is the level of detail. We can select, there's a whole full definition in here, full description of how to apply this template, right? But basically, we can select a path of objects that will be checked, right? A path, or well, we have ID patterns that I'm not going to talk about, but you can read on it if you are so inclined. And those are the elements whose LODs will be checked. we can additionally have a required subpath that says, okay, once I have all of the elements that I'm selecting in this path, I need to have these elements inside of them, right? And you can also provide a geometry surface to check that at least there's one geometry surface present in the object itself. So what does this look like? So for example, in this case, if I have this rule, what it says is that any building, right? We're going to select all buildings, and the buildings need to have a geometry with an LOD at least 2.1. What does this look in semantic space? So we have, and this is, I think, related to Nick's question earlier. How can we do, for example, check imperfect data? Well, in this case, when we're selecting the target of this validation, this target is only going to apply to buildings that have a geometry, and that geometry has a surface, right? So if the building, for whatever reason, doesn't have a geometry, or the geometry doesn't have a surface, this rule is not going to apply to it. We can tweak this, of course, but this is how the rule is being generated. And then we're going to do a check on the geometry surface. The geometry needs to have at least one surface. This geometry needs to have an LOD, and we're going to filter the LOD. This is a regular expression which basically requires that the LOD is at least 2.1. Right? And we have other examples for checking. Well, we can check non-extended LODs, right? We can check this is an extended LOD. This is 2.1. We can check non-extended LODs, 3. We can check in here that, for example, this one checks that a building requires a wall surface, and that wall surface, the geometry of that wall surface needs to have an LOD of at least 3.2. So again, we select, and then we apply the rule to those selections. And we can have more complex rules. For example, for each building part inside of a building, we require that there's a building installation, and that building installation has a geometry with a surface, at least one geometry with a surface called of type wall surface, and that geometry has an LOD of at least 2, right? We have several examples in here, depending on what one may want to do. And the other type of check is the object attribute, the other type of template, sorry. So for example, in this case, we say, okay, we need to check that all buildings have a has walls attribute, whatever its value. I don't care about the value, but we require that there's a has walls attribute. We can require the has walls attribute, and we can say, okay, it needs to be equal to true, right? To the Boolean true value. We can say, okay, the value is not required, but if it's present, it needs to be true. I think this could kind of work around what we were talking about earlier, Nick. We don't require the value itself, but if it's present, it needs to be true. And again, these are examples. These are templates, right? This is just to simplify, to make it easier for someone that's not familiar with this, or to have a starting point. But for someone who's not familiar with these technologies like SPARQL and SHACL, to have a starting point where they can build these rules, right? If you have advanced, knowledge on SPARQL and SHACL and these types of technologies, you could definitely write a SPARQL query, for example, to specify which targets is my rule going to apply, and then you can go crazy, right? You could say, I want to check all building installations inside of buildings, no matter the what I have in the middle, right? They can be building installations that are direct children of buildings. We could have building part, story, whatever, blah, 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 and then installation. And you can do that with this selector in here. Or you could check only elements. I don't know. I want elements that have geometries with a given LOD. I want to know that whenever I have an LOD equal to or higher than 3, for example, I have this attribute, or I have a semantic surface inside of type wall, so that all elements with an LOD, with a geometry with an LOD of at least 3, have a wall surface in them, right? So you can, with the target, you can define which elements you're going to validate, and then you can write the actual SPARQL query that will be run on each of these elements, right? Just by using this let's say this variable will be filled in with each of these selected targets, and then again, you can have simple rules like this one in here, where we say, okay, either we don't have a value for this attribute has walls, or the value is true, right? So this attribute is not required, but if it's present, it's true, which is what we wanted to express in here. And we have other types of rules. For example, in this case, we can say that the height is required. The height attribute is required for buildings. It has to be at least 1 and no greater than 10. Okay. Any questions, comments in here?
I think that no questions, so we can.
No, Alper wrote something in the chat. So yeah, so there have been, I think I mentioned earlier, that there have been some efforts to create a CityGML or City RDF, let's call it, right? A CityGML RDF ontology, but nothing is really official, right? You can create it. Yeah, you can create shackle graphs with Alti shackle. Yeah, that's absolutely correct. But there's nothing normative. There's nothing official, so to speak, right? There's nothing that's been grandfathered or approved by the CityGML working group. So we have there's another one that we've let's see if I can. CityRDF. So this is, for example, another version. They all look similar, although they have their own, specific details. But this is, for example, something that the OntoText people have been working on for the Czech Accord project. Sorry, where we have also a definition with, the core ontology, the core components of the ontology, the building component, and all of that. And they all look similar, but they all have their own specific, nuances and details. So that's why we went with ours, because also I think I've talked about this as well, but using CityJSON as the base for our semantic format makes our lives so much easier, because it's very easy to work with and very easy to transform into a graph format. But yeah, you're absolutely right that we could definitely, and by using templates, for example, we could tailor the way that the transform process between this JSON format and the output, so that we can adapt it to different models, not necessarily our target, our own custom homemade ontology or RDF model, but others as well. Okay, any other questions, comments? No, thank you. Okay, so I think we're actually over time, but we didn't even get to the should we continue? Maite, everyone, what do you think? Should we go on?
Yes, for me, I don't know if you would prefer.
No, I mean,
take a little break or something. You are okay?
Yeah, I'm fine. My coffee is cold, but
Okay.
good. Okay. So the idea now would be, to get on with a practical case, right? To actually test these rules. One thing I forgot to mention is that naturally, if we want to, the output in here is a full. It's not only, as you can see it in here, it's not only a single. It's not only the rule itself, but it has some other boilerplate stuff like the prefixes, these prefix definitions to be used in here and all of that. The important part of the generated rule is this is obviously necessary, but the important part is what we have inside a node shape, right? This thing that I'm declaring as a node shape until this period in here that closes it. This is the important part. So if I want to group several rules into one, right? I can start from the whole thing, right? But then I can add. I don't need to add all of the. I could. I mean, you can definitely. Yeah. Well, I don't know why I mentioned this, because you can definitely paste one after the other if you want to. It's not going to look pretty, because in the real world we wouldn't repeat these profiles and we wouldn't repeat these other objects in here. But you can paste one rule after the other. And when this gets loaded, all of the rules will be part of your validation profile. So if I were to have this as the set of validation rules for a profile, this would work perfectly fine. Okay. So the idea now is that by following these steps in here, you would create, or we as a group would create, a first building blocks register, then a profile, and then the shackle shapes for these types of validations in here, checking that there is at least one road, that all building objects have a geometry with an LOD of at least 3.1, that all building objects have a geometry with a roof surface, and that any building part object that is a child of a building has a has windows attribute with value 1. And then running the validator, and okay, how could I build? Okay, that you would have to write your own. We don't have templates for that, so you would have to write your own SPARQL query. In this case, yeah.
Don't worry about the fact that it's about doors and shop fronts, but all main and secondary roads, except residential, shall be wider than 5 meters.
Okay, so okay, the wider than, let's say for the sake of this example, that wider than the width is stored in an attribute, right? Because we're not doing any we're not doing any computations in here, right? Let's say we have a hash width. Okay, so we have writing this by hand is. Am I sharing? No, I'm not sharing my screen. I thought I was sharing my screen and I was talking about it earlier, but obviously, can you see my screen?
Right.
Okay, so let's start with a very simple rule in here. Let's start with. I thought that I was showing you all of this, but I was just talking and the presentation was on. So, so for example, did you get to see any of the rules that okay, maybe not, because I had the presentation on like an idiot. But okay, so for example, let's start with just with the attribute checking, right? I mean, doing that with this template is not really possible, because we don't have the selection criteria. It's not really doable with this, but we can start with that and do object attribute, and we paste this and we say, okay, well, we want to check roads, right? Roads. And we want to check that the attribute has width m per meter, right? Is present and is equal or greater than 5, right? Yeah. So this will be copy the clipboard, and once we have it in the clipboard, so once we have this rule in here, this rule has two components. It has it's going to fade this out. So we have the target, which is selecting roads, right? And then we have the validation, which again that every road has an attribute of hash width meter with a value, and that value needs to be at least 5. So where would we? So the thing is that all main and secondary roads or whatever. So what we could add in here is requirements for what is for example a main road and what is a secondary road. If that comes, for example, from the function, right? Let's say it comes. Does it come from the function?
Yeah. Well,
okay. So we could say, for example, that city as function is equal to X. I don't know, to whatever identifier we have in our code list, right? We were talking earlier about hash function 1, hash usage 1. Let's say that we have properly codified this and we have hash function main, right? This would only select main roads, right?
Yeah.
Or maybe hash function whatever function, and we can say let's filter function so that it's in either main or secondary, right? This would select all of the rules that have either main or secondary, right, as their function. And then we can say except residential. Okay, so maybe that comes, I don't know, in the usage, right? So city has usage, and then we say we can have another filter, or we can add it to the previous one, but we can have another filter just for clarity and say usage is not residential, right? And this would basically select all roads with a given function, and that function needs to be either main or secondary, and a usage, and that usage needs to be something other than residential, right? And we're going to apply the validation rule to all of this. And all of this will be passed to this filter in here, which is I have this attribute with this value. And this is just an example, but potentially, if you could do geometry computations in here, you could, right, compute the width, right? The width of the, yeah.
So this is geometrical doesn't matter.
Yeah. So this is why I mean, we have a lot of flexibility because we can, we can craft queries to select which specific elements we're interested in. Obviously, doing this with a template is hard because we're talking about, specific right? We're talking about specific attributes and things like that. But we could select which elements we want to apply the rule to, and then apply the actual rule. And if the elements don't comply with the rule, then the rule isn't applied. We could also have a complementary rule that says, okay, check that we have at least one main or secondary road in our data set. So that, for example, right? So for example, if you're checking a data set and you select the wrong file and you put in the buildings data set, no rule is going to fail unless you also have another rule requiring roads, right? Because if you apply this to a buildings only data set, since we're not selecting any elements, right, they're not going to fail. So that's the way that we can mix and match the types of rules.
Okay, my first point was that if I had a city model with some roads marked as usage, with their usage as being residential, then I shouldn't need to specify the function as main or secondary. And you're saying that I do. I have to put every attribute on every road. So I just that's the kind of thing that worries me about SPARQL in particular. Okay, I mean, thanks.
You can do something like this in the filter, right? If you either well, I mean, it depends on what you want to express or what your criteria are, right? So you can say, okay, either the function is main or secondary, or the usage is residential, right? I mean, so it all depends on your criteria and on your ability to write this stuff, right? If you're able to write very complex queries to select and then to apply the validations, then the world is your oyster, right? Otherwise, and again, you're also limited by naturally whether your input data is correct, right? If you don't have the necessary attributes, if I don't have a way to tell main and secondary roads apart, then this is all moot. And whether the uplift process into semantic space is adequate or not. Okay.
Okay. I'd like to continue this conversation because I think there's a big problem here.
Okay, I'm more than glad to do so. Well, we can move on and revisit, or we can do this some other time. But yeah, I'm very interested in any feedback on this. Arcadius, you had a question or a comment or a complaint? Arcadius, are you there? You can see my screen. Oh, good. That's good. Thank you, Gonzalo. So, okay. Can you do it now? I don't know. Someone muted you. Can you? Yeah, but
yes, I could unmute myself. Yeah. So my question was basically about the size of the models you can apply those rules to road this way. What would be the size of the city model, for instance, like if you can apply to this to big cities like capital cities, or it will work on smaller ones when you have like file representation, things like this. The scalability of this approach, if you could elaborate.
Yeah, that's a really interesting point. So we have just tested it with our input data sets, right, which is what we have access to. And this seems to perform reasonably well for the current input data that we have, right? Mostly we've tested it on data from the city of Ascoli Piceno. Technically, the limitation is, I think the main limitation is going to be on the memory use, right? The use of memory, because most of these, for example, the JSON LD, the JSON parser, the JSON LD parser, and all of that, they're not streaming parsers, right? They're in-memory parsers. So they take the whole JSON, CityJSON tree, they put it in memory, and then the same thing applies to the graph. So this is a limitation mostly on our own implementation, so to speak, right? On the fact that we're using a Python backend, we're using PyShackle, we're using RDF, and the way that these modules work is by loading everything into memory and then doing all of the operations from the loaded graphs. But potentially we could, this could be further modularized, and we could, for example, leverage some other either JSON LD parsers that could work with in a streaming mode, so that not everything has to be loaded into memory, and then by dumping, so to speak, all of the data into a triple store, even if it's temporary, right? And we could, like for example, GraphDB, and then performing the operations inside that triple store. And that way we could work around our current limitations. But how big is too big? We don't know. It depends on currently on the hardware that you're running the validator in. But again, the validator is just an implementation. For me, the most important part of this is this, right? Is the whole process, how we can create rules according to Shackle, group those rules into profile definitions, and then validate the data in semantic space once converted.
Okay, thanks. Yeah, that explains. Yeah, thank you.
Any other questions? So, should we go ahead and create a and at least get started on the at least do this with one? Do you think should I do it so that you can follow along, or do you? Are there any volunteers to be actually implementing or trying to follow the steps? What do you think is the best option? No volunteers? Okay. Okay, so I can show you, but you'll have the recording if you want to do it. But I can show you basically how we can get started with this, right? So first of all, we're going to create. You can see my screen, right? Yeah. Okay, so we're going to create a fork of the basic building blocks repository, right? So we navigate onto this. We have a button in this here. Use this template and to create a new repository, and I'm going to call it Jack Workshop People, right? So it's generating the repository, and then I'm going to clone it I'm going to clone the repository locally into my machine, right? So as you can see, I have something that is basically a copy of the template. It has 2 building blocks as examples, and it already has a workflow, a GitHub workflow to process these building blocks. There's other configurations that we could change, like, we have identifier prefixes. We have, there's, again, as I mentioned earlier, there's documentation on how to work with building blocks, and you can take a look at that. And naturally, you can ask me or Rob Atkinson, who is not here, very wise on his part, and we'll be more than glad to help you, to guide you, and to, we could definitely do another workshop on building blocks. But let's take the I'm going to now. I'm going to load this into my IDE of choice, which is PyCharm, and I'm going to open the project. So this is going to be okay. So this is what my project looks like. It is again the same that we've seen. I'm going to start by deleting the examples, and then I'm going to create a new building block of my own. I create a directory. Let's call it, I don't know, example profile, and I've created the folder for the bblock inside sources. I need to add a bblock.json. Okay, the easiest way to do this is to take one from, from the ones that I have in here already. To process bblocks, that's it. So, I don't know. Profiles, let's see, I'm going to take one from the dummy one, which is dummy profile is a profile that has no validation rules. Should always validate correctly. So I create a bblock.json, and I write in my sample profile, an abstract, simple profile for demo purposes. I can, change the, the dates, the versions, whatever, and I need to have a check validation profile tag. Otherwise, the validator is not going to interpret this profile as a profile, right? So next up, we need to create the shackle shapes inside rules.shackle. So we create a rules.shackle, and we can start creating the different rules. We can do so, for example, we need to check that there's at least one road, right? Well, we're in luck, because unless I'm mistaken, we have that specific example in object presence, right? We have this example in here. So we could either use the output as is, or we could just, take the road, take this example. Where is the validator? In here, or go to rule generator in the validator, check object presence, write my own rule with exclamation marks to make it seem more important, and then I can just copy this, and I can copy this, and I can put this in here, right? So right now I have one profile, which is example profile. Coherent. I have one example profile with one rule in here. Okay, no, thank you, Nick. Very interesting questions. So once I have this, right? Once I have this, I can see that, well, I've deleted the old stuff, and I can add all of the new files, right? The new stuff. I've only created bblock.json and a rules.shackle. I think I'm not forgetting anything. So I can just commit the changes and say create example role, and I can push this. Well, first I may have to pull first, because every time, and this is something that is going to happen, every time that I push something to the repository, the every time that you push something, there's a workflow that runs in here. You can see it inside actions, right? There's a workflow, and that workflow verifies that the building blocks are correct. It compiles the actual building blocks so that you can get a website such as this one and all of that. So I pull and then I push. So when I push this, you'll see that, you see, there's a pending, there's a workflow that is, well, in this case, it's queued, but it's going to run. In the meantime, oh, I have to enable, sorry, I forgot about this. We have to actually enable GitHub pages from GitHub Actions. Sorry about that. Otherwise, this is not going to work. And we're going to enable. This is basically, for those that are not familiar with GitHub, basically the URL is going to be your, well, the username that you've put the repository into, .github.io, not .com, but .io, / the name of the repo, right? And this is the URL where right now it's not. Okay. So I was too slow enabling. Let's run this again. If you do it properly, not like I've done it. If you enable GitHub pages, which I'm going to add this in here. Call from actions like that. Okay. So we don't forget. So now that the action has finished running, if we open this, we can see, okay, an example of it's very similar to what we saw earlier for the checks profiles. So we have our rules in here, right? So now the next step would be to point the validator, right? We have created a basic, by following these steps, we have created a basic profile with just the one rule. And now we need to, because the validator, as I have it in here right now, the list of profiles that it offers is the list of profiles from the check building block repository, right? So it has all of this, but we need to tell it to use our own building blocks. So we changed the data source in here, right? So instead of this URL in here, we say this comes from bblocks. Where is my repo is here. So this value in here, right? The register.json, where it says this register metadata can be found at. We take this, sorry, and we put it in here. So when we run this, if there's no errors, okay, let's see if this works. So now we only have my example profile, simple profile for demo purposes, which is exactly what we created. And if we check, we use that profile, we can say, okay, let's take this land use data set, which is very small for validation. And when I run this, I get, well, validity, validity there, but I get a shackle error. No rows found in the data set with our own message that, if you remember, I put, I typed 2 exclamation marks, right? So we know it's running the rule correctly. And if instead of, or if apart from that, if I take land use and also roads and I validate, this will generate a graph with both, with the contents of both these files. You'll see that the error has, gone away, the shackle error. Obviously, if we have problems, the geometries are problematic, we're going to have validity errors. But I didn't mention this, but you can take a look at the full JSON error report, right? The idea is that this report is not really readable for humans, but this should be if the validator is integrated into another application or used as a service, this output can be interpreted by the client, whatever it is, and it can be displayed, even possibly visually, right, on a 3D viewer, for example. So now this is the way that we can add more rules, and we can create rules, and we can add more rules to this validation. For example, let's see what's next. Check that all building objects have a geometry with LOD at least 3.1. Okay, we have a template for that as well. So we can go to the rule generator. We say object level of detail, and we say, okay, building has LOD less than. When I don't have any contents in here and I select a rule, it's going to, to put the contents of the first example, right? Of the first example for the building block, for the template in this case. So this is why it automatically filled this with path building, which is basically what we want, right? Anytime that I have a building, LOD needs to be at least 3.1. Okay, so 3.1. And we can copy this. We can paste it in the rules. We can leave it the way it is, but we can also remove all of the extra stuff, this prefix definition in here. And we can also remove this prefix definition here. It's totally fine if you don't do this, right? You can leave it as it is, but let's just, to keep it neat and tidy, we're just gonna remove it. And then again, I come in here, my rules have changed. So I added, I commit the changes, add building LOD rule. I pull, because naturally something has been generated, and I push. And we need to wait for because now the action, it takes only 37 seconds, but still. You'll see that right now, if we go in here, we open this validation. This validation file right now only contains our first rule because the workflow hasn't finished running. Once it's done, okay, it seems to be done. Let's copy. You'll see that now we have the 2 rules in here, right? And we can add as many rules as we want. And right now, if we come in here, just going to restart the validator to guarantee that it's not caching any remote files. So again, my example profile, and I can validate a file, and I can say, let's validate the roads file for this. And I get no shackle errors, right? Why don't I get a shackle error for example, for the LODs of the buildings? Anyone? Because I have no buildings. This is a roads data set, so there's no buildings in it. But if I choose a buildings data set, let's see what happens.
This was easy.
This one is going to take a bit longer because, I mean, and this ties in with Carrie's question about what are the limitations on this. I mean, these are supposedly all of the buildings in Ascoli Piceno, at least in the city center, with various levels of LOD. So what do we find? We find first that we have no roads found in the data set. Okay, that was one of our rules, and the buildings data set doesn't have any rules. And then we have a bunch of messages about buildings that have LODs that are not at least 3.1. And we have, it's by looking at the identifiers, and we have the identifiers in here, and they say, okay, city validator input files, first input file, right? Number 0, we only have 1, so there's no mystery there. The city object with this ID is failing, right? This is the one that's failing. And we can see that we have a bunch of errors in here. So the idea would be that we can keep on adding rules. All of these rules, as specifically, we can do them. We can create them by using the templates. But naturally, we could either have more templates. We could craft new templates that for other types of common use cases, or again, someone like Nick or Kerius that may have more advanced knowledge on how to craft SPARQL queries could create their own stuff. Okay, so with this, I think we've covered. Naturally, there are some more stuff that we could talk about RDF models. We could talk about we have talked about geometry computations and all of that, and we could also mention other types of rules. This is only dealing with data completeness, right? Data requirements, but there's nothing preventing us from doing other types of more advanced checks. So yeah, any questions, any comments?